Hi everyone. Let me go through some of the articles that are published in Medium. So Medium is basically a blogging site where you can publish articles. So there are some very good articles on blockchain on Medium, and I will recommend you to subscribe to these articles, not only for Hyperledger but also for Bitcoin, Ethereum, Quorum, Coda. Find a lot of good articles mentioning the details about some of the blockchain platforms. So let me walk you through some concepts, but some of the other concepts that we have not gone through. And the version that which we are focusing in this course is version 1.0, while recently Hyperledger has released version 2.0. There are a lot of changes that have been made during this transition from 1.0 to 2.0. There was a version which came in between 1.4, which has got a lot more features. So if you want to contribute to the community, you can join Hyperledger community from hyperledger.org, and you can contribute to building the newer standards of blockchain technology in Hyperledger framework by contributing to that community or by giving your ideas and proposals on how you can make the blockchain itself better. So there are developers who work on developing the blockchain stack itself, and there are developers who work on developing the applications. So that level of contribution can also be given, and that gives you a lot of opportunity for doing the research in the area of blockchain. So especially now, there are a lot of work which is being done on data archiving. Blockchain, as you know, is a ever-growing list of transactions. Data keeps on growing. How do you keep the data based on the archival policies of the organization? So that's again a very good research area. There are a lot of research which is being done on how to make blockchain quantum safe, what kind of algorithms we can incorporate so that the quantum computer cannot break the security of blockchain technology, and especially Hyperledger Fabric, which is a class blockchain framework. So lot many areas in which research is going on, and all these new features which are coming up are also the result of the newer innovations or some of the patents that are getting filed in this area. This is the first link which tells some fundamentals about Hyperledger Fabric. Let me this link. Hyperledger is an umbrella of open source project, and these are the various frameworks and tools that are available. Composer is the tool which is basically used to write your smart contracts and generate the network file or a BNA file out of it, which you can deploy on a Fabric network. And then these are the different frameworks: Burrow, Fabric, Grid, Indy, Roha, Sawtooth. So generally you have a client which has the Fabric SDK connection. Then he sends the transaction proposal to the endorser. Endorser is a special node in Hyperledger Fabric which endorse your transactions or which validate your transactions. And after validating the transaction, it sends back the transaction response to the SDK, sends back the response to the SDK, which sends these endorsed responses to the orderer, and orderer distributes these to the committer nodes. Committer nodes do not have the chain code or the smart contract because they do not validate the transaction. They just see the copy of the world state information and rewrites these transactions to the blockchain database and update the transaction to the blockchain database. SDK is software development kit. Yes. Basically, what client application will need to do is they will need to install the Fabric SDK. So for example, if you are developing the web application, what you will need to do is you will need to install the client SDK or a Fabric SDK that will allow you to interact with the Hyperledger Fabric network. It's similar to using the Web3 library for interacting with the Ethereum network. MetaMask is an application or a wallet that allows you to do the transaction for the Ethereum network. SDK is just like your Get library that we covered in Ethereum. So if you want to interact with the core Ethereum, you need to have the Go Ethereum library installed on your machine, and using the Go Ethereum libraries and its APIs, you can connect with the Ethereum network. So MetaMask is used to connect with the Ethereum, but it is not at the SDK level, it is at the application level. SDK is basically an application or a group of applications that provide you the API to connect with the core. So Fabric SDK is same as Go Ethereum for Ethereum or a Geth for Ethereum. Like you need to install the Geth library in order to talk with Ethereum, you need to install the Fabric SDK library same way. It is required for the client nodes in order to interact with. Endorsers and peers will already be having the Fabric installed on them. Client will need to install the Fabric SDK in order to interact with the peers. So these are the components that we have already seen. basically the client application, the peer is the node, and the orderer is the entity which distributes the transaction to the nodes. Client is your client application. Now your nodes can be your client, your peer, and can be your ordering nodes as well. Client node is where your client application is running. Peer is can be your endorser or can be your committer. Orderer can be any ordering service that you are running to distribute the transaction. So there are 4 categories. In fact, we initially thought that, there are only 3 categories like endorsing, committing, and ordering. But ordering peers are also divided in the latest version to 2 different categories. One is your anchor peer and another is your leading peer. So leading peer, instead of orderer doing all the ordering on its own, it divides the organization-wise orderer. So we will see a diagram of it in the next slide. So there are 3 kinds of ordering services which are kind of prominent today. When you develop an application, you want to test it using the solo ordering service because this is by default built in the fabric and this is easy to use. Solo, what it does, it just follows first out basis. So whatever it receives, it just packs it into the block and sends it across committer node and to all the nodes which needs to update the blockchain database. Solo is the simplest one. The next one is Kafka, is basically an ordering service which is developed by Apache. It has got 2 or more nodes for the fault tolerance and it distributes the load among different nodes. So even if one is down, other nodes are able to take over and perform the ordering service so that it is more fault tolerant and better with respect to Solo. It is mostly used in the production environment and not in the test environment. Now the third one, which is still under development, is the different versions of Byzantine fault tolerant algorithms. Currently you have PBFT, you have SBFT, you have different versions of Byzantine fault tolerance algorithms. These are going to get incorporated in the next version of Fabric release. Now, what will be the benefit of including the Byzantine fault tolerance nodes? It will make sure that even if there are some malicious entities, even if there is an attack on the endorser and endorser is sending you the wrong endorsement, it is able to take care of that and it is able to process the correct entities only. So these algorithms are under development. The Hyperledger Fabric community has not yet implemented this mechanism, but it is on their roadmap. Now the next concept, channel. The channel allows you to create kind of multiple blockchains within a single network. For example, if there is a bank which is interacting with multiple companies and they don't want to share their data across, so the banking nodes can be the peers for insurance company number 1. It can also be the peer of insurance company number 2, and they both can operate on different channels. One can work on red channel, another can work on blue channel. The peers in the bank will have both databases separately. They cannot basically intersect each other. So the red channel database will only talk with the red channel entities and the blue channel database will only talk with the blue channel entities. So that's the concept of channel. It also simplifies, in case there are multiple participants, and it also simplifies the problem of side chains. So you generally, if you implement the channels correctly, you do not need side chains even for testing, etc. Channels is a important concept that we use in blockchain, and there are files where you can configure how many channels you want. Although you can configure it in the GUI also. Then now you have the blockchain as a service platform where you can design that, okay, this is the diagram that I want to follow and I want to have 3 different channels and this node will be this channel, etc., etc. But there is a file called config tx.yaml, which is basically a simple YAML script. There you can mention that which all channels and which all peers are part of which channel. Then identity is basically given by your certification authority and it generally gives you X.509 authorized certificates. Certification authority can be used, the built-in certification authority that comes with a Fabric, or you can incorporate your own certification authority as well. Now ledger. So there are basically 2 kinds of ledger in blockchain. One is your world state ledger and another is your default blockchain ledger. Blockchain ledger is basically your group of transactions combined into a block, and world state is your normal database, basically a CouchDB or a LevelDB, preferably a CouchDB because CouchDB will support the SQL queries and will support the rich queries and can easily fetch the information. There are 2, and world state is not a append only database. It can be updated by transactions that are coming up, but the blockchain ledger is always a append only database. The previous transactions cannot be deleted. World state can always be validated by the blockchain database. So these are the different kinds of database. Now here you will see that the headers of the block will look like the similar ones that you have already seen in Bitcoin. So there is no much difference with respect to the form of transactions, the way they are stored in the blocks, the way blocks are organized. There is no much difference as such. But obviously there will be additional information like the channel related information, what kind of chain code it is coming from. The world state is not an optional. World state is a mandatory thing in Hyperledger Fabric. World state is not an optional thing. Whenever you are configuring your database, you will need to configure your world state database along with your blockchain database. In fact, blockchain database will not need to configure. It comes by default. But for world state database, you need to configure that which database first of all you would like to use, and what all information would you like to store in world state database. That basically comes from the assets and transactions that you define in your smart contract. Additional thing which the transaction has in case of Hyperledger Fabric is the endorsement proposal and its responses from the endorsing peers, because this is the proof that this is a valid transaction. So this proof is also kept along with the transaction detail. What was the proposal, what was the response, and how many endorsements have come for this particular proposal is also part of your transaction that you put in your blockchain database, so that at any point of time you can validate who initiated this transaction, by whom it was endorsed, and when it was committed to the blockchain database. Chain code, as you know, in Hyperledger Fabric, your smart contract is known as chain code. So you can also see this particular article. I think this covers some other things as well. Demystifying Hyperledger Fabric. It has got actually 3 sub-articles in it. It will tell you diagrammatically that whatever we have discussed, plus some of the additional concepts that are there in the newer version of Hyperledger Fabric. This is the simplest form of Hyperledger Fabric architecture that you can imagine. You have 2 organizations. One is yellow, another is red. They are connected through a one channel. Consider that there is only one channel and there are only 2 organizations. They interact the client, and there is an ordering service which is also controlled by a certification authority. What is missing here is the MSP, which is also assumed to be in CA. There is a MSP, there is a CA, which basically authorizes these different peers. Organization 1 has Organization 1 CA, which is a certification authority for this organization. It will give the certificates to be used for all the peers which are part of this organization. Similarly, Organization 2 will give the certificates to all the peers part of Organization 2. And you have this CA which will give the certificate to the ordering service. All the nodes, all the participants needs to have a valid certificate and authorization before they can participate into the network. No random entity can join and become the part of the network. So that's simply not possible. So certification authority is responsible for managing user certificates such as user registration, enrollment, revocation, etc. And it issues X.509 standard certificate, which is also the latest standard used in TLS. Now, this is the difference between the databases of your endorsing peer and committing peer. In endorsing peer, you have the chain code. In committing peer, you don't have the chain code, because your endorsements or the chain code run during the endorsement policies. In the endorsing peer, the committing peer just commits those transactions into the ledger. Therefore, they do not need to keep the chain code or the smart contract. There are different languages in which you can develop your smart contract, such as Go, Java, Node.js. We generally prefer Node.js because that is the default language which is used in the composer. Now, this Fabric basically, gives, as you know that, there is a Fabric SDK which gives you the API to connect with the Fabric. Now we have another layer on top of the Fabric, which is known as the Hyperledger Composer. Now, Composer does 2-3 things. One, it gives you the easy way of developing your smart contract. Second, it lets you test your smart contracts directly into the Composer tool. Third, it gives you the executable of the smart contract, which is called as the Business Network Archive file or a BNA file, which you can directly deploy onto the running network. So these are the advantages of using the Composer. But without also can develop your smart contracts by directly using the Hyperledger Fabric APIs. So Composer is an optional component, but most of the development till now has been done on the Composer. With the latest versions that are coming up for Hyperledger Fabric, Composer is now not recommended to be used. In fact, they have taken off the web version of the Composer. Earlier, if you just write Composer Playground, so this was the site which was running, but now this does not work. So Hyperledger community is not promoting Composer in the newer versions of Fabric. So they want people to directly start working on the Fabric APIs rather than using the Composer layer, but still you can use it. Now again, it has shown the ledger is basically two. One is your blockchain ledger, another is your world state ledger. World state ledger can be your level DB or a couch DB. You have endorsing peer, you have committing peer. Now this is a slightly broad illustration of the diagram that we saw earlier. This is your organization 1 peer. Similarly, organization 2 peer, it has got chain code, it has got ledger. You see the ledger is same, ledger A, chain code is same. So they are connected to the same network. They are only part of one single channel. And what is important to note is that there are system chain codes which are installed at different places. Now, what are these system chain codes? System chain codes are the chain codes which validate whether the transactions that are coming are valid transactions or not. Because at the ordering stage, you need to verify that you are receiving the endorsed transaction or not. Whether all the entities, for example, if the ordering service receives that peer A has validated and endorsed the transaction. So it will first check that peer A is a valid endorser or not, whether the signature which has come is valid or not. So all these things are checked by system chain. So there are different categories of system chain codes which are installed, which cannot be modified. We can only write our own chain codes or smart contracts that gets deployed on peers. But the system chain codes cannot be modified unless a new version of Fabric comes into the market. So this is one view, and then more you dig into it, it will start getting more complex. These are the system chain codes which are available. First is your QSSCC, which is for ledger and Fabric related queries. For any queries that you do in the database, this is the chain code which comes pre-installed in the Fabric. Then there is a configuration system database. There is a lifecycle system database. Lifecycle system database is for channels. Then endorsement system chain code, basically, how you will endorse your transaction, and then how you will validate the transaction. For that, you will have VSCC. VSCC will be at ordering service. So this is a bit more complex architecture. Here, what you will see is you have three organizations: organization 1, organization 2, organization 3. Organization 1 and organization 2 are connected through channel A, and organization 3 and organization 2 are connected through channel B. And they have a common ordering service which has got system chain codes and system ledgers, and the common ordering services is provisioning the transactions to the client requests that are coming to the endorsers. What is happening is there are two blockchains which are running, one between organization 1 and organization 2, second between organization 2 and organization 3, but the network is common. There is one common network, and organization 2 will maintain two copies of chain code A and chain code B, and two copies of ledger A and ledger B. Now ledger A will not have any interference with ledger B. It will be on completely different channel, and chain code A will not have any interference with chain code B. So proposal or the transactions endorsement that come for channel A cannot go to channel B, and similarly the transactions cannot be stored at ledger B. It will be completely different. So it's like one node part of the two different blockchain networks. So that way you can understand the concept of channel. So this is a bit more complex, and as you go down it will get even more complex. Client sends the transaction proposal. The transaction proposal is validated by the endorser. Endorser sends the endorsed proposal response. It again goes to the ordering service. Ordering service create the block, and it gives the block for distribution to endorser as well as the committer nodes. And then the event is sent to the client that the update has been done. Now the ordering service, we have a Solo and there is a Kafka, and the new one, which is your Byzantine fault tolerant, is coming in the newer versions. Kafka is a crash fault tolerance based service where you have multiple nodes. So this is the typical ordering service. Here it is not shown the way the ordering service is generally shown, but it generally consists of 4 nodes, and all of them are basically backing up each other. Here it is. This is your ordering service which has got multiple nodes, and it is a fault tolerant ordering service that even if certain nodes go down, the blockchain network would not go down, and your transactions will continue to flow through the system. It uses a special kind of a message queue in order to receive the information from the client, and the same message queue it uses to update to the peers. This is your Kafka ordering service, and then the new one, BFT or a Byzantine fault tolerant one, is the one which is coming up in the new versions. It will be integrated along with the Kafka itself. So you will have a fault tolerant feature as well. Plus you will have a feature that it will detect the malicious node and it will find a way to eliminate the transactions coming up from the malicious nodes. These are the different ordering service, and then you have a label DB, you have a couch DB. Couch DB is the best option for the world state database because it supports the rich queries such as JSON, etc. These are some of the new features which are not there until version 1.0. I think they come during version 1.4. So the first one is the private data collection. Private data collection is that although you have the concepts of channels where you can divide your data between multiple networks or different blockchain networks, but what if you don't want to make your system complex by defining the different channels? What if you want to selectively share the data between two or more nodes using the private data collection? This is again a new concept which has come with version 1.4, and it basically tells you that you have two kinds of database. One is your public state database where you have the blockchain as well as your world state database, and then you have a private state database which is similar to your blockchain database, like your private write set storage, which is the replica of your chain storage, and then you have a private state database. But this particular database is not a blockchain database, although it looks like a blockchain database. This private state is your private database, which is only limiting to you. And this is not shared through the ordering service, rather it is shared through the 101 message using the gossip protocol. So again, this is a feature which came after a lot of research that do we need a private data collection, and this was actually influenced from CODA, which allows you to share the information privately between two or more nodes. Based on that theme, because that was the limitation of Hyperledger Fabric, this feature came into the picture, and this was implemented in the latest version of Fabric. So you have public block storage, you have private block storage. So this is how your database looks like. You have a public state which is available with all the peers, and then you have a private state. Say for example, this particular private state is shared with org1, org2, and org3, and this particular private state is only shared with org1, and org3 is not aware about it, although they are part of the same channel. So you can have a private database between two or more peers, although they are belonging to the same channel. The other solution could have been that we could have made this a one channel, and we could have made this as another channel, but that would involve a lot of complexity, a lot of different databases to be kept. Now this is only one database, and still you are keeping your data private. That is the reason this feature was incorporated. Now the endorsement etc. process remains same. The only difference is that along with your public data endorsement, you will also have a private data endorsement. And the another difference is that this private data will not be written through the ordering service, rather it will directly go through the gossip protocol. Here you can see that this is directly going to the gossip protocol without going to the ordering service. So the ordering service is limiting to the public block storage. Then there are some other features which are also there for improving the efficiency of the network and displaying your traffic information, your discovery information, your operations information. So what happens is, because orderer has this complete load of sending the transactions and committing the transactions to the committer nodes. So in order to ease out that load, they have introduced a new concept of leading peer. So each organization will have a leading peer. Like this organization 1 is having this particular node as leading peer, organization 2 is having this node as a leading peer. So the orderer will only send the leading peers, and the leading peers will further distribute it using the gossip protocol. So the orderer will not have the responsibility of distributing the entire block to all the nodes. This specifically comes handy where your network is large, you have many nodes to distribute, and you want to keep the ordering service simple and straightforward, and you want to distribute the load of ordering service with the use of leading peers. Again, these are all configured in your config.yml file, and you can define any node as a leading node along with endorsing capability as well as the committing capability. So this is the concept of your leading peer. So let me come to the anchor peer now. So now there is a feature of service discovery. Again, this is a new feature which has come in the latest versions of Fabric. Earlier, what was happening was that, in case there was a node which was down, so there was no way to identify the node as down unless you start getting the failed transactions from that particular node. So that was causing a lot of problem because, for example, if your endorsing nodes goes down, then your transaction starts to get fail and your application starts seeing that red, that your transactions are not going. So in order to make the network availability checked, so there was a concept of service discovery which was introduced in the version 1.2 of Fabric. Now there are specific nodes in the network which are called as anchor nodes or anchor peers. The role of these peers is to collect the stats from different peers and to basically check whether they are working or not. So you might have heard about a message which is generally used in the network that is called as keep alive message. Basically what they do is they generally keep on sending keep alive message, whether you are alive or not, whether your stats that you should have are active or not, and then it gets the response and it actually updates the client. At the client side, you can see the dashboard in the real time that which organization, which peers, which endorser, which ordering service, which committers are alive and are working as per the defined capability or not. This makes your job easy with respect to the network configuration. So if you are an admin, you would like to monitor that how your network is behaving, and then in case a course correction is required or you need to add more peers or nodes capacity like memory and storage, then accordingly you can take the decisions. In order to enable this kind of a discovery, you define anchor peers. Again, this is defined in your configuration file, and this is again works on your system chain code where you define the interval. After that particular interval, it will keep on checking the availability of the network and it will keep replying to the client. So this is the anchor node or a anchor peer. Similarly, you can have health checks, you can have operational metrics, you can have log level management. This concept is through this Prometheus. So you can have a node which can get you all this information, like your health check, etc. So I think this is a very good read. If you also see, this guy publishes a lot of articles on blockchain. So again, this is a very good read in case you want to go ahead with the blockchain development in Fabric. These are all the resources. Now what we will be concentrating is like how can you write your applications in Composer. So Composer, what it basically does is it gives you basically four things. First is your asset, participants, transaction, and events. What is your asset? Asset is basically the entity that you want to transact in the blockchain network. The primary blockchain network is that without any intermediary you can transact the assets. Participants is all are basically the participants who are entitled to own or transfer this asset. And then transaction is basically that you want to define, for example, if you want to enable a gold trading, then what transaction, for example, if I would define a transaction where one trader can pass a gold from one trader to another under these conditions or under this smart contract. So that will be your transaction. An event will be the events that you send it to your GUI application. Now, GUI application is connected in Hyperledger Composer using the REST API framework. Similar to Web3 framework that we have in Ethereum, you have the REST API framework. REST is again a open source implementation. So you connect with the backend and front end. Your front end application will use the REST API to basically call the functions on the backend API, and your Fabric SDK will sit in between. So Hyperledger Composer is an extensive open development toolset and framework to make developing blockchain applications easier. It accelerates time to value, makes it easier to integrate your applications with the existing business systems, allow you to model your business network. Basically, when you define your asset, participant, and transaction, this is called a modeling or a model file, and we call it as a CTO. So we will see that what CTO is and how it exactly looks like. Applications use business-centric APIs to invoke transactions that create, delete, and update assets. Asset participants and transactions are recorded in boiled state in register. So whatever asset participant and transactions you clear in your model file, they will go to the boiled state as a ledger information. So what are the advantages of using the Hyperledger Composer against directly using the Fabric is it increases understanding because you have a clear segregation of asset participants and transactions. So it becomes very easy for a developer to write an application. It saves a lot of time, reduces risk, and increases flexibility. These are the files that we generally use. One is your model file, where you define your asset, participants, and transaction and events. Then you have the access control list. Access control list basically gives input to your MSP, and it basically which participant has got what access. So, for example, if there is a participant A, can he also manage the assets of participant B, or can he only manage his own assets? So those kind of accesses are basically given in the access control list, and eventually they get configured in your MSP, and accordingly your certificates are issued or the identities that you create in the network. And then you have a transaction processor function, which are nothing but your smart contract or the chain code, which basically tells you that against which transaction, which function I will run, and how that function will, basically store my values in the world state and the blockchain data. At last, you end up creating a business network definition or a business network archive file, which you can deploy to the Fabric network, and your network will be up and running, and you can deploy the BNF file, and that will basically complete your this thing. So if you see the overall structure, you have a model file, which you call it CTO file, where you define assets, participants, and transaction. You have a JavaScript file where you define all the functions related to these transactions. You have an access control file where you define what rules you want to put against each transaction and participant. And then you have a query file where you can define that, okay, what all queries will I use to basically fetch the information from the world state database. And together, all these four become your business network archive, or basically the executable file that you deploy onto the Hyperledger Fabric. This is your overall architecture of Hyperledger Composer. This is the command to basically install your Composer Playground. And after your Composer Playground, you will need to install the Fabric. So these are the commands to basically install your Fabric. First, you will need to get it from these packages, and then you need to run this script, download fabric.sh. Then you will be able to basically install the Fabric on your computer. Now let's come to this Fabric. If you have installed all the tools, this is how your directory would look like. You will have all the scripts that you need to basically start your Fabric network. The first thing which I want to showcase is that how the composer works. Command I will need to do is composer playground. We'll run a composer. It basically runs in a web window. It already says that this project has been deprecated. It has by default opened a trade network because this was the last network that I was working on. Let me try to show you how it initially comes. When you open it for the first time, this is the screen that you will generally see. This is your composer playground where you can create your different networks. So what I will do is, I will deploy a new business network because I am creating a new business application. These are some of the sample networks which are available, which you can use to basically create your skeleton. So I will choose basic sample network to begin with, and then we will also go through the trade network. These two networks we will see. Rest of the networks you can just open and try to use yourself. I have selected basic this, and then I will need to give some values here. This is basic sample network. Give the admin card, like for example this. Let me connect to the already created network. So this is my basic sample network which Composer creates for you. Now you can modify this the way you want. So as you will see that it has a readme file which will tell you all the information about this network. Then it have a CTO file. CTO file is basically where you define your asset, you define your participants, and you define your transactions. First thing that you need to do is, before you define your assets, transactions, etc., you need to define your organization, and you need to define your organization with the namespace. So your organization is example.basic, and you have defined a namespace for it. So each and every function related to the transactions of this organization will need to have this syntax before it. This organization is basically named as example.basic, and I have created a namespace for it. Now you will see that these are the definitions that you generally give in Go language. So you have got asset, you have got participant, and you have got transaction. Now participant is basically a structure which is identified by participant ID. So you have a concept of primary key here, where you can identify a particular structure with some sort of a primary key or a ID. So your participant has nothing but your participant ID, first name and last name, and all three are string. O means they are part of this particular structure, and if there is an arrow means it is coming from some other structure. So O is basically a natural value and this is basically your reference. This is my participant. My participant will only have first name and last name and a participant ID. Now this is my asset. Asset is basically predefined using the asset keyword and it is identified by asset ID. So again the primary key. Asset ID is my string. Now this asset will belong to a participant. So therefore I will need to define a participant inside the asset. And I am using it as a reference because the participant is defined somewhere else. I am defining the owner of this asset and I am defining the value of this asset. And all these are string, like asset ID is also string, value is also string, participant is your participant ID, first name and last. And what transaction I am allowing is, I am allowing a transaction where I am transferring this asset to a new value, where I am modifying the value of this asset. So I'm not transferring it from one participant to another. What I'm doing is I'm modifying the value of this asset. So what transaction I have defined? I have defined an asset. This is my asset and I have defined a new value. The default value will be here. And what also I have done is I have defined an event says that whenever there is a change in the value of the asset, I will be sending an event to the application where I will mention the asset and I will mention the old value as well as the new value. Let's see this JavaScript file where we are defining this. So now what we have done is, since we have defined this sample transaction, we will need to implement this transaction. How will we implement this transaction? We will need to rewrite the value of the asset. What we will do is we will get the old value, we will update it with the new value, and then we will write it to the blockchain database, and then we will emit the event. So that's the code we are going to write in a transaction implementation function, which we write in sample.js or our chain code. In our chain code, although this is mentioned in comment, but this is a must mention comment. Okay, if we remove this comment, this program will not compile. We will need to mention that which transaction function we want to implement in this particular format @param org.example.basic.sample transaction. So this is my org.example.basic and this is my sample transaction. So I'm implementing this function in a chain code. So therefore I'm writing this. This is my sample transaction function where I am getting the value of current transaction. I am copying it in an old value. I am updating the value with the new value, and these are the functions which are available in the composer, which are basically your getter function and your setter function. Now this is my getter function which gets me the current value of my world state. What value I am getting? I am getting the current asset value, and then I am updating that asset registry with the new value tx.asset.value which I have updated. I'm just passing it to update. So basically I'm getting the value and I'm updating the new value. Then I am emitting this particular event here where I'm updating the value of event, like asset is my transaction asset, old value is my old value, new value is the new value, and then I emit this, just similar to what we do in Ethereum. These are the standard functions that we have in Composer, like get asset registry and asset registry update. This is a asynchronous call. These both of them are asynchronous call. So they do not return the value in the real time. It takes some time and the code has to stop till the time they basically return the value. So therefore await is returned before them. And these are the functions which are available. And in Fabric, it actually converts to get value and set value for it. Those are the Fabric implementations, these composer calls. This is my permissions.acl file where I define the rules, and this is defined in a JSON format, in a plain English like format. What rule I am defining is that everybody can read this particular business network. Everybody can submit transaction for sample transaction function. Anybody can submit a transaction. Now, who can access the asset? The asset can only be accessed by the owner. So what I am doing is, this is my resource R, which is holding this sample asset, and this is my participant P, which is basically doing this transaction. So I am making a check that my resource is belonging to this particular participant or not. If not, then I will not allow to modify the value of that asset. Basically, so if there are say two participants A and B, and A wants to modify the asset which belongs to B, then he will not be able to do so. Because I have created this rule which will directly go to the MSP and will not allow the modification to be done of B's asset by A. These kind of things are not available in Ethereum or in Bitcoin, not even in Quorum, that we can restrict the access individual participants who are participating in the network or who are actually creating the asset. And there is a clear definition of what asset is, what participant is, what transaction is, and all these values will go to the world state information as well. Now the good part about this Hyperledger Composer is that after writing this code and this CTO file and this your permission.acl, you can simply test it directly in the composer itself. What you need to do is you need to go to test. Maybe I will delete the existing participants and transaction and also the assets. There is no participant, there is no asset. So first of all, I will need to create the participant. What does the participant contain? The participant ID, first name and last name. So let's say participant ID is 1. Let me create first participant set Saurabh. So I have created this one participant. Now here you can see that it has been created. So let me create another participant. Admin is running this. Admin can do anything. I will also show you that how you can create individual users. Let's create another participant. Let's participant ID is 2. So first name is Varun, second name is Kishore. So I have created these two participants. Now let me create the asset. Now asset, if you remember, there were 3 fields: asset ID, asset owner, and value. Let's say my asset ID is A1. Let's say this is my asset ID, and let's say I want to give it to participant 1, which is Saurabh. So I will give participant ID 1, and just see that this is a reference. So therefore it is coming directly that I can refer to the first participant. And let's say the value of this asset is 100. So I've defined asset A1 with the value 100 and it belongs to participant 1. Now let me also create another asset, the asset number 2 with the value 200 and it belongs participant number. So I have created 2 participants and 2 assets, and I have allocated asset A1 to participant 1, which is Saurabh, and I have allocated asset 2 to participant 2, which is Varun. Now let me try to do the transaction. So here you can see that in blockchain all these add asset and add participants are registered as transactions. If I want to see the hash and the value, I can see here. This is the timestamp, this is a transaction ID. So this has been added to the block. Now, for example, if I want to run the transaction function, I will need to click submit transaction. So what I can do is I can change the value of any asset from one value to another value. Now, for example, now just remember, I'm running this from admin. So admin can change anything. I'm not running it from individual ID. Let's say I want to modify the value of asset A1, new value, which is say 400. Here its value was 100. Now its value is 400. If I submit this transaction, this is a successful transaction and I can see the transaction ID, and it has also emitted a event where it mentions the old value as 100 and new value as 400. So this is a very simple and basic example of using Hyperledger Composer and creating your own business network. Now here, I'm running it from admin. So therefore, admin can basically modify any asset. That's what we defined in our permissions.acl. Now let me try to log in via individual credential. Instead of going to admin, I will go to ID registry. Let me, remove all these already existing IDs. For participant number 1, which is sample participant, let me create a new ID. What was the name? Saurabh. And let me give him the first participant ID. So that Saurabh is the participant number 1 and I am issuing him the new ID. Now, instead of using admin, I want to log in via Saurabh. I will say use now. The network will get refreshed. And just remember, this is a simulation, real or a live network here. Now let Saurabh try to modify his own asset and let him also modify the asset of Varun. Okay, let's see what happens. So if I say submit transaction, now let him modify his own asset first. So his asset ID is A1 and let him modify to 700. Let's see if it has happened. Okay, so it happens successfully. I can see the transaction record. Now it has modified to 700. The event will show the earlier value was 400 and the new value is 700. Similarly, let me try to do the same transaction via Saurabh's login to the Varun's asset. So let's see if we can do that. So let me try to modify asset number 2, A2, and let the new value be 1000. Let us see if I can do this. It gives me the error that sample participant 1 does not have update access to rows sample participant asset A2. So which means I'm not authorized to do that unless I create an identity for Varun and associate it with the sample participant 2. I will not be able to modify his asset. These are the the basic features which are available in Composer, where you can write your chain code, you can define your assets, participants, and transactions. You can define your ACL file, access control list, where you can tell that which participant has what access and which asset can be controlled by. This is a very basic example, and once you run this, then what you need to do is you just need to say export, and it will create the BNA file or a business network archive file for. So if I say show in folder, it will basically save it in a download location, whichever is configured for you. It will create this BNA file, basic network BNA file. Yeah, this is the BNA file, I guess. This is how simple it is to basically create a application in Composer. Now let's see one more application. Let me try to run this trade network. This is a trade network, where you are trading the commodity. Let's see, what this example basically tells us. So let's first see the participant. There is a participant called trader. Now this is my namespace org.example.trading. This is my organization under which I am creating this network. I have a participant called trader, which is identified by trade ID, first name and last name. For example, if there is a gold trader, so his trade ID is gold and there is a first name and last name. And then this is the asset that I am defining, that there is a trading symbol, there is a description, there is an exchange where this asset is basically hosted, there is a quantity, this asset, and there is a owner, there is a trade owner. This is the asset that my trader will have. Now this owner, which is basically coming from this particular structure, will have the trading symbol, will have the description, will have the exchange, and will have the quantity. Now this is my asset, this is my participant, and then I have got transactions. So basically, I'm defining two transactions. This one I have left as blank, so just ignore this. This is the transaction trade where I am defining the new owner of this commodity. This commodity, which is my asset, if I want to transfer it to the new owner, then this is my transaction which is there. And then there is another transaction, remove high quantity commodities, where I will be removing the high valued commodities from my system. This is another transaction is there. Now let's see the logic.js file. So logic will be implementing your trading.trade, which is my transaction. This is my transaction where I am transferring this commodity to the new owner. So my logic.js will implement this. What it will do is it will get the value of the new owner. It will again call this getter function of this commodity into the asset register, and then it will create a new event, and then it is calling the update function, where it is updating with the new owner and it is emitting the event. So the same functionality that we have already seen in the one is your getter and another is your setter function, and in between we are emitting a event. Similarly, it has implemented another transaction, which is my remove high quantity transaction. Now it is again checking that what is the definition of high quantity, and based on it, it is removing those particular transaction system, and it is also emitting a remove notification event. Now, do I have anything in the permissions.acl? In the permissions.acl, if you will see that allow all participants to access the resources, permit all access to all the participants, and network admin user has all the accesses. So we have not restricted any access in this network. We could have restricted here also, but here we have not restricted anything, so all users can do all the operations. This is the basic network that we have for the trading. Now let us see how it runs. If I go to test, let me remove the existing traders. Let's add a new participant. So I'm adding a trader. Let's say T1 is the trade ID. Name of the trader is This the last name is that. Okay, I have created the first trader. Let me create another trader. I've created another trader Ulink. These are the two traders that I have created. Let me also create a commodity. Let's say trading symbol as main exchange. So let me give this trader one, which is Tejasvi. Trader ID is T1. So I'm giving this asset to. You can see all these transactions getting created. I have assigned it to trader T1, which is Tejasvi, and my transaction ID. This is my timestamp. Everything is going to blockchain as individual transaction. Now, let's say I want to do a transaction. First of all, because I have defined two transactions, it will ask me that what transaction I want to. Let's say I want to do trade transaction, where I will say that okay, I am transferring this commodity to the new owner. So commodity is basically identified by a trading symbol. In trading symbol, I have given as gold. I have given it as gold. If I want to submit a transaction, a trade, if I want to transfer it to T2, it is successful. I can see that I have transferred the gold commodity from T1 to T2, and this is my transaction. This is my event where it will show that okay, this transferred, and this is the event ID, this is the timestamp. It has not mentioned the new owner and the old owner, which I think which should also be mentioned in the event. Similarly, you can see multiple examples which are already given. So if you say deploy a new network, it will give you many sample networks that you can choose. We have already seen basic network and trade network. You can choose vehicle, life cycle, letters of credit, fund clearing, digital vehicle property. All these are examples, and then you can also create your own. So as an outcome of this, you get a BNA file which you can deploy Composer network. So now let's see that how we deploy this BNA file. First of all, how do we run this Composer network? Then how do we deploy this BNA file to the network? The entire environment, you will see these different scripts that you might have installed on your machine. Now, and this also has a BNA file which I have just copied after creating it from the sample network. Now, first of all, before starting any instance, you will need to see that, if there is any existing instance which is running. There is already the instance of Fabric which is running. You can see that, this is all running as Docker instances. Okay, these are all running as containers. There are different, basically, scripts, flows, and to start the Fabric network. Now, I will run this script tear down all docker.sh. This will basically kill all the instances that are currently running. So if I see Docker, now it is empty. Now, in order to start my Fabric, what command I need to give is start fabric.sh. This is the command that I need to give basically to start the Fabric. It will by default start for one CA, one certification authority, one orderer, one peer, and one couchDB, one world state database. By default, this is the configuration that it starts with. If you want to modify the configuration, you can go to the config.txt inside your sample network folder, and then you can modify the configuration, and then again you can do start fabric.sh. If you want more instances or more peers, then you can change the configuration. So currently I am starting with the default configuration, where you can see it is creating couchdb, it is creating orderer service, it is creating certification authority, it is creating the peer, and it is created one org1 as a default organization. Now all this is configurable. You can modify it based on your requirement. This, it has created the network. Now if you want to see the network, see it in Docker peer. You have all the instances running. You have a peer, you have a certification authority, you have a couchdb, and you have a ordering running. Now, in order to deploy your BNA file or smart contract to this network that you have just created, you need to create a peer admin card. That means you need to create an admin entity or an identity of an admin which can deploy this network. For that, there is a script which is called as create peer admin card. Now I will run this script, create, and you will get all these scripts once you install your Fabric network, the steps that are given. So here it has created your peer admin card. Now with this help of peer admin card, you can deploy your smart contract to the network which is running here, this network. Now, what is the command for that? Need to see that out. This is the composer command that you will need basically install your BNA file. So now what is the name of the BNA file? In my case, it is tradenetwork.bna. Now it has installed the business network. It has installed the BNA file, trade network version 0.2.6. Now I can just start it with this particular command, and now I can just start it with network start. Then I can call the individual APIs from the application that I create. That creating an application you will not be able to cover, because one, it is not part of your curriculum, then it's a very lengthy exercise of creating the REST APIs and web application to do this. But I think have a good study material in case you want to learn it. You can basically learn it from this documentation which is available here. How do you create business network definition? Steps that we have already done. How do you create model files, script file, ACL file? How do you define business network? All this documentation is available. How do you deploy these business networks command that we have just used, the install as well as the start? What are the rules that you can give in the ACL? How do you emit the events? How do you basically developing business network? And then it will also give you the tutorial for how do you connect it with the REST APIs. So if you go to developing applications, writing web applications, you can see that how you can connect it with the REST API. So till now what we have done is we have done deploy BNA, we have generated the network admin card. Now the next step is to start the REST server or the REST API server, and then you generate the Angular app or a web app which connects with this REST API. These are the steps that you need to follow. We have done this start fabric, we have done peer admin card, we have done the installation, we have done this, the start of this network. Now the next step is basically to composer REST server. Give this composer REST server, and you need to attach your application with this from the steps which are giving here. This is what you need to do in order to further work on this application or any application that you create in Fabric network. Theoretical concepts. Hyperledger Fabric is a permission system where members of the Fabric enroll through the membership service provider or MSP. Offers several pluggable options. Ledger data can be stored in multiple formats. Consensus mechanism can be switched in and out, and different MSPs are supported. So everything is plug and play. Also offer ability to create channels, allowing group of participants to create a separate ledger of transaction. So channels also we have seen in detail that how it basically segregates the chain codes as well as the databases. Now, what are the key benefits of Hyperledger Fabric? Compare it with Ethereum, with Bitcoin, and with Coda, and with any other permission network. It is the most feature-rich blockchain implementation till date. And that is the reason it is number one choice for an industry-grade application development in the market. The amount of features that Hyperledger Fabric has, let's say for example channels, let's say for example private data collection, let's say for example archiving methods that are there, not many features which a business commodity, a business data requires in their system are enabled only through Hyperledger Fabric as of now, and no other blockchain system is so much rich. The only disadvantage of using Hyperledger Fabric is that the development and the configuration of the network is somewhat complex when you compare it to some of the other implementations like Ethereum, like Coda, like Quorum. So comparatively, they are much more easier to configure, deploy, and test. While you have to go through multiple tools and iterations in order to completely test your application and deploy your applications in Hyperledger Fabric. So the benefits are data protection and consistency because it is permissioned. So if you are a owner of your data, nobody else can modify it. Confidential transaction, no cryptocurrency, so it does not have any built-in cryptocurrency. So it basically goes away from the notion that the blockchains are only meant for financial application. It is in a form true implementation where can make any industrial application from blockchain network, and it is a fully programmable. You have a choice different programming languages that you can choose to build your program. There is no cryptocurrency. It is a permission network, while Bitcoin is a public and Ethereum is also public. Transaction is confidential. There it is anonymous. Consensus is proof of work or proof of stake, and here it is PBFT. Rather, currently it is, if you say Then smart contract is none in Bitcoin. In Ethereum, it is solidity, and in Hyperledger Fabric, it is chain code, and it is based on Node.js, Java, or Go language. So these are some of the capabilities like identity management, privacy, confidentiality, efficient processing, because there is no overhead as such. You have well-defined network entities who are doing their certain operations. You're not replicating information too much. So you are not basically installing chain codes at every node. You are selectively putting the database based on the channel configuration that you have done. You have segregated public data and private data effectively. So processing is very efficient. In fact, this is the only blockchain that has more than 1000 TPS or 1000 transactions per second supported in a live network. Chain code functionality and code logic that is invoked by the special types of transaction on a channel, system chain code defines. So there are system chain codes and there are user chain codes. System codes basically define what the system is going to perform based on the transactions that you have initiated, whether you have correctly endorsed it or not, whether you are using the right and ordering service or not, etc. And then there are user chain codes where you are doing based on your application. Then design is modular, everything is plug and play. You have assets, you have chain code, you have ledger. Ledger is basically your CouchDB or LevelDB where you have SQL-like queries capability. You have channels, you have security and membership service, and you have consensus. Now, these are some of the participants. And if you ask me, these all of them basically converts into the blockchain related jobs or blockchain related roles. So you have a blockchain network operator who basically designs your network, how many orderers, how many peers, how many endorsers, what kind of some configuration is required. There are the blockchain developers, there are regulators, who basically oversee all the transactions and confidentiality clauses. There is a blockchain user, which are basically your application users. There is a certification authority, which gives you the credentials of using the blockchain. So all these are basically the blockchain roles. Then there is a database guy, which defines that, how your world state database will look like, what kind of optimizations are needed there. So there is a blockchain user which interacts with the blockchain using LOB application. There is a blockchain regulator, which is the overall authority of a business network. There is a blockchain developer, which develops your smart contract. There is a network operator, which basically manages your blockchain network. There is a certification authority that gives you the valid credentials of using the blockchain network. There is a traditional processing platform, and there is a traditional data source. You need to have a computing system. So the components, so we have a ledger, we have a world state, and we have a blockchain ledger. We have a smart contract, we have a consensus network, we have a membership service, we have events, system management capabilities. Like we saw that we have a log monitor, we have a event monitor, then we have a wallet. Wallet, we already see that we can create the individual credentials. In the composer, you saw that I created different entities like Saurabh and Varun, and then you have system integration, where you can integrate it with the external systems or external application, or we call them as oracles. So these are the typical APIs that your application use. So for example, if it wants to buy a new contract, then the function or a query that it will use is deploy. If it wants to use some data, then it will use query, and it wants to invoke any function or a transaction processing function or a basically your transaction, then it will call the same thing in Fabric layer is done through get state and put state function. The developer who deploys the contract, and this is smart contract. Basically, there are two ledgers. One is your blockchain ledger, another is a world state ledger. There is a put state, get state query through which the world state ledger is created. And there is an SDK, which is there with an application which is used to basically interact with your blockchain layer. Now, this is for Fabric 1.0. We have already seen the documentation for 1.4, and now it is even available for version 2.0. So you must also see that what new features has 2.0 brought in. That is a very, very new release, I think few weeks back only. So even I am not much aware about the Hyperledger Fabric 2.0 when they release a new version, telling that what are the differences from the previous version. So what's new in Hyperledger Fabric 0.0? Multiple organizations must agree on a parameter of a chain code, or deliberate chain code progress, simpler endorsement policy, private data collection updates. These are the new features that they have incorporated after 1.4. In 1.0, they have endorsement model, they have pluggable external identity server, can have any certification authority. So certification authority and MSP also ties up with the LDAP server. So in case your organization has a LDAP server which maintains the registry of all the users in your organization, then your CA can also tie up with that and basically issue the certificates based on your LDAP registry as well. That is also something that even I have implemented for one of the Hyperledger implementation. Plugging external database is also possible. Then you have historical queries, you have HTTP based SDK, and you have chain code. So this SDK interacts with the blockchain layer using the HTTP queries. So HTTP layer, it is not a socket based connection, it is a HTTP based connection where you send these queries like invoke, deploy, run, all these queries, you send it via HTTP commands. These are some of the features like you have channels for sharing information, you have ordering service which delivers transactions consistently to peers in the network, you have endorsement policies, you have CouchDB, you have MSP, again same thing. This is also something that we have seen that we have an endorsing peer which sends back the endorsement respond in terms of your read write set, and which goes to the committer which commits these transactions to the blockchain network. So committer peer, basically there are three kinds of peer: committer, endorser, and orderer. And orderer looks something like this, because especially Kafka, which is a multi-order service, we generally denote it like this. There is a enroll, proposal, submit transaction, and then just updated using the ordering service. So these are the APIs which the SDK use. Like upgrade API is used to upgrade the smart contract version. So for example, what happens is if there are changes in the smart contract and you want to deploy the new smart contract to the existing chain, then you need to use the upgrade API from the SDK to deploy the contract or the new contract. That finishes up your Hyperledger Fabric. Thank you so much.